So this video looks at the derivatives of trig functions, and I've got some examples there, but let's write down first off the derivatives of sine, cos and tan for this lesson only. So the derivative of sine x is cos x, the derivative of cos x is minus sine x, so they're linked, and the derivative of tan x is sec squared x. So you need to remember those three, and then we're going to do some work with them. Now, it's very rare we just have to derive a sine x or a cos x. Of course, we will get questions like that. But normally it's going to be like the ones you can see here where it's sine 4x, tan in brackets 3x plus 1, 2 cos x cubed. So we need a more complex rule that copes with that. So just remember that the derivative of sine is cos, the derivative of cos is minus sine, and the derivative of tan is sec squared. That doesn't change. So I'm going to add, I'll do it in red. Now I'm going to write a little rule here that's actually an extension topic. And so for 2 units, you don't actually need to know it, but it's the reason why the rule works, and I'll explain it in a minute. So we're going to do it in red. The rule is, if you've got d dx, and it works for the other two as well, sine, and you've got some function of x. The derivative is f dash x, so you get the derivative of what's in the brackets, sine, and then you simply rewrite what was there, f of x. And that works for cos and tan as well. So I'll write those down in a minute. The reason it works is the following, and this is the 3-unit bit, the extension bit. Basically, we've got, let's say we've got y equals sine x cubed was the one we were looking at. So what we do is we let u equals x cubed. Okie dokie. So now we've got y equals sine u. And what we're trying to find is dy dx. So dy dx equals, well, at the moment what we've got is y equals sine u. We don't have any x's in there, so we need some way to link the y with the x. And what we do is, it's like a fraction. We can cancel common factors top and bottom. We've got dy du times du dx. Now if you think about it, if you cancel out that du with that du, we've got dy over dx, which is what we want. And we can find dy du and we can find dy dx. So dy du, well, that means the derivative of y with respect to u. Well, that's just cos u, and du dx means the derivative of u with respect to x. Now, we said over the page that u equals x cubed. So du dx equals 3x squared. So du dx is 3x squared. So if we put that all together, we've got that dy dx equals dy du, which is here, cos u, times du dx, which is 3x squared. Now that's well and good, except we don't need u's in there. It's in terms of x, so we need to replace that u back with what we first substituted for. So u is actually x cubed. So it's cos of x cubed times 3x squared. And that follows my rule from before. My rule was f dash x, and it was times, get the pen happening, the derivative of sine, which was cos, and then rewrite f of x. And that's what we've got. F dash x was 3x squared times cos, and f of x is x cubed. So for 2 unit, you can just memorise the formula. Basically, you find the derivative of what's in the brackets, put it at the front, change the trig to its derivative. So from sine we went to cos, and rewrite the original function. But for extension 1, this is something we're doing later on, deriving with rates and rates in 2 variables. So you might just remember this splitting up concept for later on.